Okay, before we move to today's presentation, I would like to start with a few information. So as most of you may know, we are organizing a conference, BIOMAT conference at Le Croisic beginning of May. We extended the deadline for abstract submission and registration, although I encourage you to register soon because the places are limited and we are soon reaching the limit for registration. I would like also to remind you that we still have two presentations for this specific series of women in science. So if you're interested, just check our social. You should find the link to register individually to each of them. And with that, I would like to introduce today's speaker, Malgorzata Wlodarczyk-Biegun. Sorry, I did my best. Not sure the pronunciation is perfect, but I think you will repronounce it afterwards. Who is currently an assistant professor at the University of Groningen in the Netherlands, but also an associate professor, if I'm not mistaken, in a university in Poland. And I will not give further data because it's also the point of today's presentation. So with that, I would like to give the mic to you, Gosia.
Thank you. Thanks a lot. So I just please let me know if you see the presentation in a full screen. Yes, I cannot hear, so. Can you tell me? Because
sorry, we don't see any presentation from your side yet.
You don't see any presentation?
No. So yeah, you're not sharing.
I'm not sharing. Okay, then I will. Maybe something goes wrong with this oversharing, I guess.
Yeah.
Okay, then let me start sharing again. I think now you can see something, right?
It's loading.
Yes? Okay.
Yes.
So, yes, so thank you very much for the invitation. So my name is Gosia Wlodarczyk-Biegun. I think the pronunciation was almost perfect. And indeed, I will share with you not only my science, but mainly my path or my way to go to the point where I am now. And I also included some scientific slides, so you can maybe also see what you are doing and get some connection, and maybe there are some options that we can in future also work together. So indeed, where I am now, so I lead the biofabrication and bioinstructive material groups, and I work at the University of Groningen, so that's northern Netherlands. I'm also currently the chair of Dutch Society for Tissue Engineering and Biomaterials. And in the same time, so here I'm assistant professor, although yesterday I had a discussion if I will be promoted. So let's see, because hopefully since next month, I have a chance to become associate professor here. Interestingly, I'm associate professor at the University of Technology in Gliwice in Poland. That's the south of Poland. And sometimes it brings also interesting situations because in Netherlands for the defenses, if we are associate professor, we wear toga. When we are assistant, we don't. And then for some of defenses, when I was asked to represent Poland, I could wear toga. And when I represent Netherlands, I cannot wear. So it's like sometimes I feel like two people in one body. But it's just one of example how interesting it is actually to work cross-border. And in this cross-border setting, I lead the group. So I have a group members that are in Poland and that they are in Netherlands, but we also try to make exchanges. And here you can see some of these people. I didn't updated photos. This also reminds me that actually I need to make photos of people in Poland and in Netherlands, or maybe make a joint meeting also to have a nice group image. But in general, you can see that we have quite some members. So here you see that in principle the blend of people who are in Netherlands and in Poland. I have also some previous group members, but we are relatively new because the group is like around 5 years now going on. And then we also have a close collaboration, or we had a close collaboration with Markus Koch. So I would like to, that's a SEM specialist, but I just would like to first acknowledge all these people that helped me with the science and to be where I am and to enjoy what I'm doing. I also want to acknowledge both universities which gave me the options, or are still giving me the option to lead the joint research, and also the granting agencies, because I managed to convince some people that what we are doing is interesting, and we received quite some funding. And I would also like to talk about it and show you my way to the position where I am, but also to discuss a little bit the funding, how I got it and in which order. So to introduce a group a bit more, so we are specialized in biofabrication and bioprinting. So what we do, we position in principle different biomaterials and cells in a very well organized manner. We look on how the cell interact with the material, and we try to communicate with cells to discuss with them and to force them or to convince them that they can differentiate and they can form different tissues. And especially I'm interested in a hierarchical structure. So of course, you could argue that each tissue or all the tissues are hierarchical and are complex, but for us, the most interesting are the tissues which are kind of on the interface, so that on the small length scales, we have differences in the material structure, composition, and chemical and biological, or that they are occupied by different cells. And here you can see some examples of our work. So we work with skin that you usually distinguish 3 layers: epidermis, dermis, and the fat layer, subcutaneous layer. But then also each of those layers is stratified and it's complicated. So that's where our interest goes. We also work on hard-soft tissue interfaces, so the connection between hard tissue like bone and soft tissue, for example, tendon on the muscle, is very interesting because the fiber placement or alignment and the chemical and biological compositions are really changing on the span of a few millimeters or like a sub-centimeter range. And recently, we also start to work with breast tumor microenvironment, and there we work on the heterogeneity of the extracellular matrix and the complex composition when it comes to the stiffness of the material and the type of the material that is present in the tumor microenvironment. And our approaches include different bioprinting technologies and biofabrication techniques. I started with melt electrowriting, and then we did quite some work on working with this technique, where we have a molten polymer in the cartridge, and then it is deposited on the printing stage in the presence of electrical field. And in this way, we can really well control the placement of the fibers. What is very specific and very beautiful in this technique is that you can position really precisely how the fibers are placed. And because of this, you can get interesting structures with a very good control. And then recently, we moved more into bioprinting and extrusion printing using hydrogels and specifically microgels. And in our case, we pack these microgels very closely, and we also put into each of the microgels or into different microgels different functionalities and specific dynamic properties. So the microgels together form the ink, but this ink can be heterogeneous because we can kind of steer behavior of the separate microgels. And all of this, and it's a kind of, I think this is the only private slide, but there will be more private information coming. So also kind of please keep it to yourself. And I know that this seminar is recorded, but that I would ask to later kind of blur the images, because I put here also my family, but it's just to kind of show you that it's possible, and from my side, highly encouraged to combine the scientific research and scientific career with having some fun, having family, doing your hobbies and whatever you like. So I think there are many inspiring scientists that are doing, for example, art or doing some sport on professional level and having fun. And I think it's good to remember that it really helps, and it's possible, and I will discuss this a little bit more later on also. So to explain how I get to the position where I am, or how it worked for me, I would start. I was thinking actually how far I should start, because the main thing, or my main issue, is that I have a problem with decision making, and I like to do everything. And starting with my education, I did my master's studies in Krakow, in the south of Poland. But then before actually going to master, I already had a problem. Do I like more to work in kind of a humanities, or am I interested more in studying philosophy, psychology, in my case, Polish literature, because I'm originally from Poland, or more I'm into the STEM. So that was all the time a problem for me, what I choose. And actually for the master studies, I first decided for humanities, and I did master in psychology. But at some point I thought, okay, that's maybe not my thing. And then already writing the master thesis was kind of more from biopsychology. And then at some point we also decided to make a computational model to analytically check how people get attention, and how attention models are working using queuing task. So this is a little bit how this queuing task works. So it means that if you are kind of forced or attracted by one element in one position, if the targeted element is in the same position, you will spot it faster than if your attention goes to one place and then the target element that you should spot is in the other place. And in principle, together with some other scientists, we developed a model that you could see the set of images on the computer. You were clicking as just to switch the image, and we were recording where your vision goes, and then we were modeling how this queuing task is valid or not. But after this, I thought, okay, or actually during studying psychology, I thought it's still not satisfying me fully. So I started to study biomedical engineering, and then my bachelor thesis were on degradation of some resorbable polymer fibers. And the master thesis I did on hydrogel biomaterials for bone tissue defects. The interesting thing is also that when I was studying, I thought, okay, I in principle don't want to go abroad, but during the final year, I was asked if I would like to go to Nijmegen, so to Netherlands, for Erasmus exchange, to write my master thesis there, and to work on master thesis there. And then I think, okay, someone asked me, I cannot say no, so let's try it. I went to Netherlands. I got in love with the country, and also with the idea that I could stay there longer and do my PhD and earn some money, because in Poland at that time, the PhD was like kind of a third grade study, so you didn't earn any money. You were just doing your research, having some courses, so like regular studies. And then I thought, okay, this is amazing. You can be in Netherlands, a very nice country, a lot of good equipment in the lab, and then not only you do what you like, but you even get paid. So that was for me kind of fascinating thing. So from this, first, maybe my take-home message to you is that decisions are always difficult, and sometimes you're just undecided. You change your mind, and it still can work out very well. Because for me, it worked out very well. So I end up in Wageningen doing my PhD. And it was, again, a kind of good luck, because I just found the advertisement in the internet that one group that I had no idea about is working with hydrogels. And I thought, okay, I know something about hydrogels, why not? And actually, this original project would not be the best match, but it appeared that in the same lab, they have another project that is actually in collaboration with the same group in Nijmegen that I was visiting for my master's studies. So I was perfect candidate for them. And for me, it was also perfect, because it was about the protein-based polymers, how to use them for tissue engineering. And we produce these polymers in a recombinant way using yeast. So the yeasts were modified, and they were producing the proteins that then I needed to collect, purify, and make hydrogels to grow the cells and to produce the scaffolds for bone regeneration. And after this, I had a really a good time in Wageningen. I decided to pursue the postdoc again abroad. And from this period, my take-home message for you would be also that you don't always need to have a perfect plan, because for a postdoc, for a PhD, I didn't have a perfect plan. I thought, okay, let's just go and do some science abroad. For a postdoc, I also didn't have a perfect plan, but again, it worked very nicely. So I get to know about one group in Germany that I read a little bit, that they also work with materials, with RGD, so cell adhesive domains, that I was using during my PhD. I knew that my supervisor knew a little bit the person there, so I asked, okay, could you introduce me and could you ask if they have a position? And she did it. They had a position, so I moved to Saarbrücken. At first, I got there for the short discussion, and I was accepted. And it would work again perfectly, because in principle I didn't know what I should do there, so there was no really advertised position. It was more that I came there, it was a new group, and the group leader was also becoming a director of the institute. She wanted to make some changes, so it was not like a pre-advertised position with a clear plan. And then at the first meeting, she said, okay, Gosia, I want to actually have here a biofabrication lab. So here you have a folder from a guessing company. We know that we want a printer from them. Have a look what is available, decide for yourself, and just establish a lab. And it was a great for me, because I always liked the idea of 3D printing. I moved to Saarbrücken 10 years ago. So that was then the bioprinting was not such a boom like it is here. It was really kind of starting, so there were not so many labs with printers or established printing labs. So I was interested in the technique, but I could not really benefit from the knowledge of people around, or I didn't know anyone who was setting up printing lab before. So it was a lot of learning by myself, but it really helps me with the career later on. And also what helps me that I got really promoted when I was in Saarbrücken. The institute was part of so-called Leibniz Association, and they promote females in science. I got there the L'Oreal Prize for females that helped me a lot. I established this printing lab. So in general, that brought a lot of end recognition and knowledge, practical knowledge, and very nice beginning of a independent scientific journey. And at that time, I also at some point decided that I would like to leave, that I want to become independent. I want to do my own stuff. And the message from this part of my journey is also that even if you feel that you are not ready, like I was feeling, okay, how do I manage now with setting up printing lab and deciding which printer and which tools I should buy if I have no idea. And then later on, I was also not sure if it's a good time to leave and stop being a kind of a dependent postdoc to become an independent person. But I thought, okay, let's try. That it was a good choice. So the message is, even if you feel not ready, probably it's a normal, and just try to make a next step and give it a chance. So after this time, during my postdoc in Saarbrücken, I also started to write independent grant, and I was lucky to get a so-called VENI grant. So it's a personal funding for 3 years that fund your position and give you money to perform the research. And also, almost the same time, I get a grant to go back to Poland to start a small research group. And there was the moment when, again, my undecided nature came into the game, because I didn't know which one to choose. And I started to, in principle, doing both. And this is how it started to have group into places. And one more thing that I wanted to add here is that both positions in the beginning connected to the grants were fixed term, so they were not permanent. And in the end, now I have a permanent position in Netherlands, but I applied 3 times. So I had my own grant, and then I applied 3 times, and I was trying to get agreement to have group in both places and to have a permanent position, and it didn't work. So only the third time it worked out. So the message from here would be to just stay resilient, don't give up, and you will get to where you want to be. And now I would like to maybe kind of shortly show you what we were doing in this last 5 to 3 years, because my permanent position and really like official group that I started in Netherlands started 3 years ago, and then in Poland 5 years ago. So that's more or less the time that the group exists. So as mentioned, we are working on these hard soft tissue interfaces or multi-layer or complex tissues like skin, or for example, human tubercular meshwork. And for these studies, we mostly use multi-electrowriting. So here I wanted to give the credit again to people who helped me to work on the human tubercular meshwork. So that's a small tissue in the eye. It's positioned here, and it filtrates the aqueous humor from the anterior chamber, so from your kind of eyeball, to the episcleral vein. And when it's blocked, it builds up the pressure in the eye, and then it presses the nerve, so people start to lose vision, and the glaucoma is developing. And we wanted to reconstruct this mesh. So we were using multi-electrowriting to make different patterns that kind of reconstruct or recapitulate native tissue, and later on we seeded the cells on them in the dynamic and static conditions, and we were checking also how the drugs are influencing performance of the cells to be able to rebuild the tissue. The second part, or the second group of our projects and studies, was connected to interface between bone and tendon, and here we were trying to reconstruct a smooth connection between these different areas and how the fibers are positioned. So you can here see some of our prints using multi-electrowriting. It was a very hard work because the technique is beautiful, but high precision is not easy to get from practical perspective. But we were able to obtain these smooth gradient zones. And then also in the lab, we constructed the mechanical stretching device in which we were putting these scaffolds, and then they were undergoing cyclic stretching, and we were seeing how the cells are growing on the scaffolds and how they can align, and what is happening when you keep the scaffolds in static and dynamic conditions. And from this slide, I would like to only show you that, and I would like you to remember that what we observe is that in the static conditions, first the cells are usually following the lines that you give them, but that at some point when the scaffold is overgrown with the cells, you don't have any more alignment. But if you use the dynamic conditions, so you stimulate the cells, they will align again despite the high cell density. We also had a project on the multi-layer tissue skin in that case, and then we reconstruct dermis and epidermis, so we only focused on 2 layers, and we combined the multi-electrowritten mesh that you can see on the right with the hydrogel. So here you can see also our scaffolds after 7 days of culture, and you can see that in 2 weeks we were able to kind of develop artificial skin, although the cell densities are still lower than we would like to have in an ideal model. And then you also can see some connection to our papers if you want to read more. Another interesting project that I want to show you that, and these projects, so the other 3, I think that's maybe interesting for you, were connected to this independent grant that I obtained for myself. But then we managed in Groningen to also hire the fellowship students, and they supported me. And some of the work was also connected to the grant in Poland. And then during working on this project, I also get to know the company that was producing another material, POTPPT. So that's a kind of elastomer that can swell in water, because normally we print with PCL that it's not swelling. And they just wanted to, that someone test the material for multi-electrowriting. So it was kind of accidentally we talked with them, and it appeared that the material can be multi-electrowritten, and that it, depending on the type of the material, can swell to the different extent. And then with one student, we tried and we check, okay, if we have these different swelling materials, we combine them in one print, would they kind of have any shape morphing properties, or would they change the shape? And then what we did, we used multi-electrowriting of 2 different material layers, less swelling and more swelling, that you can see here in blue and red. And again, not going to too many details, I just wanted to show you the movie what happened. So we have a flat scaffold, we put it in PBS, and then it very quickly rolls, and we have a tubular scaffolds that now we are also having many partners that are interested how to use it. And one of the examples where we want to use it is, for example, vasculature or neuron contacts. And then finally, in the end of 2024, I received my ERC sorting grant, and there the group kind of shifted to work a lot with soft microgels. So we are still doing multi-electrowriting, but I'm getting very excited about this project. So here we have a lot of small spherical hydrogels that we pack together and then we print them. We can give them different functionalities. So here you have one example when actually we work based on PNIPAM that can change the size depending on the temperature. So our materials are can reversibly change the size, and they can be also dissolved by increasing the pH. That's one of the example, and currently we are working on a little bit more complicated system, which is based on thiols, and then depending on the reduction and oxidation processes, we can swell the microgels, we can cross-link the microgels. And not giving again you too many details, you can see that the system is printable and that the printing quality is changing depending how much of reductant and oxidant we are providing in the system. And we can also change these properties locally, increasing the heterogeneity of the microenvironment. And this connect me to the next part of the presentation. What I would like to tell you a little bit about the funding, so how I was able to fund this. So firstly, I mentioned you that I got the VENI, this personal funding that led me to move to Groningen and found my position. In the meantime, I got a fellowship student, but I also applied for so-called XS grant. This is 50,000 euro that it's just given for the project maximum of 1 year when you have a very bold question and you would like to just try and check something if it works or not. So that was a very nice set of funding that helps a lot. And after I also received the funding to go back to Poland. It was funding by Polish agency for scientists who were abroad before and they want to pursue the science or scientific activities in Poland. And then it was also subsidized with another 400,000 euro grant strictly for science, so not for the group formation. And with this funding, I was able to kind of set the biofabrication and bioextractive materials group. And then in 2023, I got kind of a new set of funding. So I got one more grant from the Polish funding agency, but it's a kind of bilateral grant. So here we have a partner from Germany and a German DFG. So we have a joint project. And then I was also able to obtain ERC starting grant for my own personal research. And then finally, the first team funding, which is funding that goes to Poland, but it's supported by European Union. And here we do the skin-on-chip models, but again, funding that allows to hire PhD students. And finally, also in Netherlands, I'm embedded in the consortium that is funded by UBO Embus Fund, connected to, let's say, the university in Groningen. And this also allows to hire one more PhD student. So there is quite some funding, but also to give you a clear perspective. So I don't know exactly how many grants there will be. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Around 9 grants, but I think during the same amount of years, I applied at least 30-something times. So I'm sure that last year, because I needed to make a kind of a very quick overview, so last year I applied 9 times, and from those I got only 1 grant. So my success rate would be 10 to 15 times %, but it's just that I really like it. I especially like to write grants with other people, although I'm more successful in the personal grants, unfortunately, because I would like to have more collaboration. But yes, I think it's a part of every scientist's life that you get a lot of rejection, and you just should not carry it with you, but go on and apply for new stuff. In the meantime, besides collecting the places where I work and the grants, I also grow my family. So first of all, my first child was born in the end of my PhD, and it was kind of decision made by me and my husband, and we thought, okay, we would like to have a child now. And in principle, in my case, it works really nicely because I deliberately wanted it in the end of a PhD. So I finished, in principle, my experiments, and then I know that, okay, now I have a writing time and I want to have my baby. So it doesn't always work so easily. But in our case, planning was perfect. And then we moved with a small child to start that I could start the postdoc position. And I mean, I started relatively quickly. So my daughter was 6 months old when I started the postdoc. And then in the end of postdoc, I also wanted to have another child. So my second daughter was born just before we moved to Netherlands for the assistant professor position. So in my case, like a new baby, new country. So then also in 2023, before like officially starting the group, I also gave birth to our third daughter. So that's how it worked in time. And I need to tell you that first of all, I mean, each of these kids was born in a different country, which is interesting experience by itself, but also at a different career stage. And I would not say that it was easier or more difficult in any of these times. So, I mean, I think there is never a perfect moment and there is never a bad moment. So all these times had their challenges and they easy going parts. Yes, so that's how we end up with 3 daughters. And then when it comes to also passion and fun, so one of the things that you can see on the images is that I have a horse and a donkey. I was always a horse riding person and a big horse lover. So I bought my horse during my PhD, and then he was traveling with us. And unfortunately, my first horse died 2 years ago. So now I have another one. But he was following me across the borders. And then the donkey joined the horse at the moment when we start to have the horse in front of the house, because at some point with 3 kids, it was a kind of decision that this decreased the amount of time that I need to do to travel to the stable where the horse is. So if I want to enjoy everything, I need to decrease the time that I'm spending, for example, on traveling and also on doing things that I love a little bit, but still I can do all of them. Another thing that you can see here is that we are a big dog lover. So we had the dog for 2 years that was on the wheelchair. He died, unfortunately, also last year. And it was a challenge, but I mean, it was our dog for 12 years. So it consumed a lot of energy and time to deal with a dog that is on the wheelchair. But again, having a combination of love from the family and animals and the excitement connected to work, I think to me gives a nice balance that if some things are not working in one place, you can kind of compensate in the other. And if you have a problem at work, you can relax with animals. And when you are tired with animals, you can go to work, for example, and do some completely different thing. Another thing that for me helps to combine family and work is taking my family for the conferences. So, for example, here you can see all of us on World Biomaterial Congress in Korea in 2024. Sometimes it's a challenge to organize travel for all of us, but still I really like it and I enjoy. And then here you can see how I'm doing with my kids, the cold water swim. So it's another thing that for me, it's I really enjoy it. And actually, it was introduced by University of Groningen. So as an exercise for the staff members to relax a little bit more, we were offered training in cold water swim. And at first, I was super skeptical, and I thought, okay, this is a little bit crazy. But again, my nature not to say no decided that I went for the training just to see how it works. And then I started doing this. I also really like running, and sometimes I run with kids. And at some point, there was the only option, so I was running with a trolley. But then again, what I would say is that if you are decided that you can a little bit reduce your effort but still do all the things you like, it's possible. So I do think that I'm not the best sport person, and I'm not the best scientist, and I'm not the best mother, but at least I have all the elements, and I try to make them as much fun and as good as possible. And I think with this, I would like to finish and thank you for your attention. And if you have any questions connected to the career path and to the science, you are very welcome to ask.
Thank you, Gosia, for this very inspiring talk. Maybe I would like to start with one because your career path made me think about it. I think I always hear that to get this permanent position or be successful as a scientist, it's always about having the luck of being the right person at the right place at the right moment. Would you agree with that?
Yes, and I would also add that you need to help your luck. So especially, I think in the beginning when the positions were not permanent, I have a lot of luck that I was not helping, just applying here and there, and then everything turned out positively. But at some point when you want to have a permanent position, I would say, okay, maybe you need to find the good people that you know in time that the position is open. And you should at least be, for example, visible in the field. But if you can somehow, I mean, for me, I got the permanent position at the university when I was doing my postdoc, but still I as I mentioned, I applied 3 times. So twice. So I got the so-called Rosalind Franklin Fellowship. So it's also the funding that support females in science. And first time when I applied it, they told me, okay, I'm not independent enough. And then I thought, well, I'm not independent enough. There was another position open that with the same kind of framework, but in a different department, and they wanted to someone who is even more kind of longer time independent. They wanted 5 years after PhD, and then I was only 3, and I thought, okay, I'm anyway applying. I think it's especially common to females because the study shows that females, if they are not ticking all the boxes, they will not apply. And then guys, even if they, I don't know, tick 50% of the box, they will still apply. I mean, we should apply even if we are not ticking all the boxes. That's one of the things important to do. And then actually for this second discussion, I was only rejected because I didn't want to resign from Poland. And so I didn't have the seniority they wanted, but that was not the problem. And only the third time I kind of was I was successful, but then people already knew me in the university, right? So I would say it's helpful if you discuss with people below you are before, and you are visible, and you help your luck.
Okay, good advice. And then I will start we start having some question in the chat. So one question is, how did you know that bioprinting, biofabrication was truly the field you wanted to pursue? And if it hadn't worked out, did you have other alternative in mind at that time?
So for sure, I didn't have any other alternatives in mind. I mean, I was not the one to. I think if I would have to, I would find other alternatives. But I'm more like, okay, it's as long as, I mean, if you write a grant, then you need to put alternative, and then you have plan A, B, C, D, whatever. But at the moment, I was not really applying for any grants. I found the position. I went there not even thinking exactly what I will do. I knew I want to work in tissue engineering somehow and the biomaterials field. And I didn't know how successful will bioprinting, but I just liked the idea, so I was happy with the task of setting the lab. And I mean, that's a kind of convenient when you are a postdoc. You maybe don't need to worry too much, especially in the beginning, how the field is going, because you are kind of hired on the project. So you do what you need to do. And I think also now I'm maybe more looking into the future. When I was a postdoc or PhD student, I was not looking too much ahead. I was thinking, okay, whatever I'm doing, I'm just doing, and let's see what will come.
Another question is, at which moment did you feel that you are at the right place, and you are the right person to do that? At which moment did you had this feeling? If you had it at some point.
Yeah, no, well, so I think only when I got really permanent position and I started to have my group, I feel that, okay, I'm a right person in the right place. Although as I kind of finish the presentation, that I do often feel, okay, I'm not the best mother, I'm not the best scientist, I'm not the best horse riding person, or oh, I could do this and this better. So I don't know if it's a moment that you really think, okay, you are the best. I mean, I feel I'm the best person and the best play is only when I'm giving a interview for the grant, because then you need to say I'm the best. Otherwise, I always think that I could improve on there. Perhaps there will be many more people who are doing my job better, but I'm just doing the best out of myself. And yeah.
Another question is, for early career researcher, do you have any advice on how to secure your first funding? How did you prepare your first grant application?
Yes, so when I was writing my first application, I collaborated or discussed with more senior scientists. So I would say that's very helpful if you have or a good mentor or a good person that you can reach out. And if you know, for example, to which university you would want to go and which funding is available in the country, then I would just discuss with this person, can you support me? I would like to come to your group. For example, I don't know, with Marie Skłodowska-Curie Action, when you want to have a postdoc, there are many universities that offer help if someone wants to go there. So I would say don't do it alone. I'm also, in principle, for each funding that I got also later on, I always share with the other scientists to get the feedback. So I'm not on the side of being afraid, oh, someone would see what I'm doing and now they will steal the idea. But of course, I'm not sharing people that I completely don't know, but I'm sharing my projects and listening what is the feedback. And when it's critical, I'm trying to take the best out of it. So if your kind of a friend or colleague is criticizing, this means that reviewers probably would also criticize. So even if I feel like internally, oh, they are not right, I know, okay, this means that how I wrote, it's not clear. Yeah, so I would say connect with someone who is more senior and ready to help you.
Yes, definitely. You need feedback, this for sure. Maybe I will switch to a more science question. Someone is wondering if you investigated the cell interaction dynamic within your microgel that you showed in some slides.
Yes, so we are now putting the cells inside the microgels and in between microgels, and we are at the moment that we try to see how they will survive the process of integration with the material and printing. And in the next steps, we want to exactly see the dynamics, so how they interact with each other depending and on the material type and also on the chemistry that we are including in the microgels.
Okay. And since we are moving a bit to science, I also have a question myself about the, I think it was the antithesis project. You show that with the mechanical stimulation, you have alignment of the cells. And I was wondering if you also checked if in the matrix that is synthesized, because I assume considering the amount of cell that there is matrix, do you see an alignment also of, I don't know, collagen fiber or other organization of the matrix? Did you check that or?
Yes, so we also could see the changes in the organization of the matrix. So we could not really see the differentiation into specific cell lines, which we wanted to see, but the alignment, that was the thing that was relatively simple to achieve from the side of the cells.
Mm. And did you check if after the cell culture, that I don't know how long it was, the cell culture, if you could improve or change the mechanical property of your finite material? Did you assess that?
But in which way do you mean? So
because of the cell, since you have a very dense
composition.
amount of cell and the synthesized matrix, maybe it would change your mechanical property in a good or a bad way. I don't know. Did you check that? Or?
Yeah. So in that case, I mean, we didn't per se make a mechanical testing, but indeed, for sure, we would have the improvement of the mechanical properties, because we don't have here we didn't have any hydrogel matrix, but we had polycaprolactone fibers, which are pretty stable. So then you have a more material deposition and you don't have really the degradation.
Okay. Another question in the chat: how do you manage to keep a balance between your work and your personal life? And since you sometimes bring your family to Congress, do you still try to set clear boundaries between the two?
No, so for sure, I don't have a clear bound. I have no boundaries between two. That's for sure. So, for example, when my third daughter was born, I was sharing an office with a male colleague. So we had a system, and I was breastfeeding. So we had a system when I was hanging something on the door that he know, okay, now it's not time that you enter the room, and in the room we have a baby bed. So, and I also because you forgot these things very quickly. So one of my former PhD student, no, one of my current PhD students recently, she reminded me, oh, do you remember when your daughter was crying and you had a meeting? We were all walking in the corridor and babysitting. So for sure, there was no boundaries or not too much. What I try now to do more, well, I mean, one of the boundaries, for example, that I never work on Sunday. So that's a time that I never respond to emails, and that I try not to even read them. I mean, I don't open the laptop, but of course on the phone I have the notification that they are still not switched off just in case something serious happens. So usually I just have a quick look or on a WhatsApp, but I'm trying not to answer on Sundays. So the Sundays are for family, but besides this, it's kind of very kind of fluent for me, and I think that's for me how it works. So I know that if something happened at home, I can go and stop mostly my work for the moment, but then I also work in the evenings, or I kind of have it connected. And for me, what is also super helpful, and I think it's fair to say, is that my husband is working not a full time, so he's giving a lot of support. He's doing websites, so he has also the freedom to, I don't know, when we go for the conference, he can work also from there. So he's not kind of restricted by his holidays. But then I still kind of feel that it's balanced, although there are no clear boundaries.
Okay. We don't have more questions in the chat, but maybe I would like to finish with an open question. Where do you see yourself in 10 years from now?
Okay. Yes, that's a very good question. So I think probably I would just continue what I'm doing. So I would like to push forward what I'm doing with bioprinting, and the part that I mentioned briefly about the dynamic materials and how my scaffolds can change with time in response to the cell, but also how actively we can change them by providing different simulation. And I would like to also see my research more applied. So I would like to go into the transfer of what we are doing into the really working tissue models, but also go more to have a work with clinicians that would be applied. And if the question would be more going to direction, how I'm going to still deal with my family and work with two countries. So I mean, 10 years, it's a long time, because then also the kids will be much bigger. So it's then difficult from the personal perspective to say what will happen there. But I would like to also keep this cross-border connection, because I think it's a beneficial for science and for students. So that's more or less the plan and how I see it.
And I guess for you, because I think you're always happy to kind of go home when you go back to Poland, I guess, no?
Yes. But then, of course, let's see what will make me happy in 10 years, because then I'm 10 years old there. But for now, yes.
Of course. Okay, with that, I would like to thank you again, Kosia. Thank you for accepting our invitation. I think people really enjoyed the talk. It was really inspiring and interesting. So with that, I would like to conclude. I will just give back again the few information I gave at the beginning, because everyone was not connected, but just to remember that our BIOMAT conference is approaching soon. We extended the deadline for abstract submission and registration, but places are limited, so don't wait too much to register. And we still have two presentations to go for this month. That you can register. If you just check, if you find us on our social, you should find the link to register. And with that, I would like to wish everyone a very good afternoon, and thanks again, Kosia, for this talk. And yeah, see you to next webinar.
Bye. Thank you very much. Thank you. Bye-bye.